Yep.
Wait, I need to write this down.
Thank you. All right, guys, are there any questions over any of the homework assignments before we start?
No, I didn't get the chance to do it last night.
Okay. If there's no question over the assignments, what we're looking at today is more factoring. We're going to be doing more factoring today. So, when we look at factoring polynomials, these quadratics, when we factor a quadratic, there are 5 main steps that we go through. First one is greatest common factor, 2 sets of parentheses with 3 spaces. Then we find the sign, factors of the first and third term, and then we check it. So the first one we're looking at is this one here, 8x squared minus 56x plus 48. Is there a greatest common factor between these 3 terms? So we're looking at 8. Because if we factor 8 out of 8x squared, we just get x squared. Minus 8 factored out of 56 is plus, if we factor 8 out of 48, we get 6. So 8 is the greatest common factor. We can divide it out of all 3 terms. We do put the 8 out front, and we have this here. So that takes us to step number 2, which is our 2 sets of parentheses with 3 spaces. And that takes us through steps 1 and 2. Step number 3 is define the sign. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the third term is, so the signs are the same and they match the sign of the middle term. Negative, so that means they're both negative. We have both of them as minus. Questions on this here so far? Brings us to step number 4, which is the factors of the first and third terms. The factors of x squared are x and x. Now, if we look at the factors of the third term, 6, we have 1 and 6 or 2 and 3. Yes. I don't know. Which one do we want to try first? 1 and 6 or 2 and 3? 1 and 6. And if we check this here, just kind of as we've been going over this week, we don't need to really check x times x because that will get us back to x squared, because the reason we had x and x is they're the factors of x squared. It's going to go back there. 1 and 6 we don't have to check because 1 times 6 is still going to be 6 because they're the factors of 6. The ones that we do need to check are the middle term. X times negative 6 is negative 6x. Negative 1 times x is negative x. And if we combine these like terms, negative 6x minus x is negative 7x. Is that the middle term we wanted? Yes. And that's it. Now the 8 is a part of the answer. We have to have the greatest common factor of 8 included in our answer. Questions on this here? Questions on any of this so far? Be ready for the next one. Factor each polynomial. So we're going to factor this quadratic, 14x squared plus 31x plus 15. Is there a greatest common factor? 31, I do not remember off the top of my head, but there's a good chance 31 is prime. Yes, 31 is prime, so it wouldn't have factors besides 1 and 31, so there are no greatest common factors. So we'll move on to step 2, our 2 sets of parentheses with 3 spaces. Finding the signs. If the third term is positive, the signs are the same and they match the sign of the middle term. So they're going to be the same and they're both going to be positive. First and third terms. So the first term is 14x squared. The third term is 15. But with 14x squared, well, the only way we can get x squared is x and x. Since it is a part of the first term, in the first spot in either one of these here, we would have x and. If there was a variable in the third term, we would put it in the third spot. Since that's always going to be there, we'll go on and include it. That way we're not looking at it in all the factors of 14 and 15. Now, I probably noticed yesterday on some of them I don't list the factors out, some of them I do. I don't normally list them out if there's not any other than just one set of factors, like 3 is 3 and 1. Let's put up 4. That's it. There's 3 and 1 or 1 and 3. There's only one set of factors. 14, well, we do have 1 and 14, yes? 2 and 7. Is 3 a factor? Because it'd be 3 and I think it's 4 point something. 4.6 repeated. Is 4 a factor? 5 is not a factor, so, and that's pretty much it. Because the only one after that would be 7, it's already listed. So those are all of our factors of 14. 15 is 1 and 3 and 5. With finding the factors, I would always start with 1 and whatever the number is, then do 2, 3, 4, kind of going down in the list. And once the two sides meet, the factors on the left really meet the factors on the right, and I mean the numbers themselves. Because the only number after 3 for 15 would be 4, and that would be 4 or 3.75. The two numbers have met. They're going to overlap. Does that make sense? So these are our factors. Now, let one of y'all pick 1 and 14. I'm just going to put the 14 here. We'll put the 1 there. We just pick one of the factors, plug it in. Because when we check it, it'll let us know if those are correct or not. 15. 3 and 5 or 1 and 15? I'm just going to plug them in like this here. Now the last step is to check. X times 15 is a positive 15x. We could write the plus in front of it. We don't need it. 1 times 14x is going to be positive 14x, which gives us a 29x. We're close, but that's not quite it. So we need to switch something. We can switch the 1 and 15 and have it as 15 and 1. So when we check this here, 1 times x is x. 6. $15 times 14x, I believe it's 214x. 210. I was a little off. Which is 211x. Okay. Well, put that back up there. Okay. Okay. 2 and 7. 2x times 1 is 2x. 15 times 7 is 105. 105x, which gives us 107x. We're trying to get 31. We could. I'm going to say switch 15 and 1, because if we did switch it, we would have 2 times 15, which would be 30, and add 7 to it, we get 37. We can do 3 and 5. So we can try this here. 2x times 5 is 10x. 3 times 7x is, and 10x plus 21x is, so that is the correct set of factors. There we go. So that one there took us a few tries to get there, but we did get there. Questions on this here? I really need to fix these slides so they're not as grainy. Looking at this here, is there a greatest common factor? No. 2 sets of parentheses with 3 spaces. Step number 2. Step 3, find the sign. If the third term is positive, signs are the same and match the sign in the middle term. If the third term is negative, the signs are opposite. Well, third term is? So they're both negative. Since the third term was positive, the signs are the same. They're both going to be the same sign, and they match whatever the middle term is, so they're both negative. Minus and minus. Questions on this here? Now, the next step is to find the factors of the first and third term. Well, x squared is just x and x. Factors of 2 are 1 and 2. Where do we want to put the 2? First one. We're technically putting 1 in the second, but 1 times x is the same as just x. We don't have to write the 1. Factors of 5, bless you. 1 and 5. Where do we want to put the 1 and where do we want to put the 5? 5 right here and 1 here. And again, with any of these here, we're going to pick a setup, check it, and then go from there. 2x times negative 1 is negative 2x. Negative 5 times x is negative 5x. Negative 2x minus 5x is negative 7x. Is that the middle term we wanted? So it's not always going to be the case that we have to switch or rearrange things, because there are some times we'll get it on the first try. Questions on this here? Any questions on any of this here so far? We're ready for the next one. Three x squared minus 14x plus 8. Is there a greatest common factor? No. 2 sets of parentheses with 3 spaces. Find the sign. Well, the third term is positive, so the signs are the same and they match the sign of the middle term, which is negative. So we have negative and negative. Now we need to find the factors of the first and third term. Well, we have x squared in the first term, so one of its factors, or part of it's going to be x and x. And we will have factors of 3, which are 1 and 3. We'll stick to the same pattern of just putting 3 in the first. It really doesn't matter. We just got to pick one. So we'll put it there. Factors of 8. So we have more than one. I'm going to go on and list them out. 1 and 8. 4 and 2. So we can do this here, and let's check this. (3x times -2), thanks. -4 times x, -4x, and exactly it would be -10x. Is that what we wanted? Now, I normally switch the constant terms, the factors of 8 first, in this case. As we switch those, 2 and 4. 3x times -4 is negative 12x. -2 times x is -2x. Yeah. Yeah, that's one way you can do it, because luckily with this interactive board, I can erase it a lot easier than y'all can, so you can do that. What I also do, we haven't had this yet, but most of the time we don't run through a full set of factors. But if we said, I could have done it on the previous one, 1 and 8, I try it, it doesn't work. I switch 1 and 8, it still doesn't work. And I've tried it with every method. I will come over here and mark it out to remind myself I've already tried these, it's done. Or especially with greatest common factor, where we saw on the previous or yesterday, if there is a greatest common factor, if there's not one to begin with, or we've already factored it out completely, there can't be one in either set of parentheses. I'm going to put this up here. Let's just say 4, 1 times 2, 2 times 2. And let's say 12. 1 and 12, 2 and 6, 3 and 4. Here, and the reason I picked it is because of 2 and 6. With the 1 and 2, or 2 and 2, no matter how I set this up, in both of these cases, I will always have a greatest common factor, yes? It is automatically gone, because there's no way to set it up. If there's no greatest common factor to begin with, then I had these as the factors of the first and third term. It's gone. But if that's still kind of confusing, it's fine. Because, and not the fact that it's confusing is fine, it's just, even if that makes sense right now, that's great. If not, the checking step still takes care of it. That's the one nice thing about this. Because some of these tips and tricks, if they make sense, awesome, utilize it. If they don't, the check will take care of it anyways. Does that make sense? Yes, because that's why I like this method, because even if some of these tips and tricks that I give you along the way don't make sense, this method here, doing it without them, still works. It's not something that you absolutely need. It's just a way to get rid of some of our checks so we don't have to do them. Greatest common factor is a no. Yes. Yes, we will get there. Right.
If we get the wrong sign later on, but the right number, then we just switch.
Yes. So we'll do signs first. Since the third term is negative, the signs are opposite. If we do have them in the wrong spot and we get the correct middle term's number of 19, we can just flip the signs. If we do get that, it's an easy switch.
Like, we're looking for -7, but we get +7. So we just switch.
Yes. Yep. Either way works. Factors of the first and third term. Well, factors 4x squared. We do have x and as it was stated earlier, 2 and 2. Got the factors of 4. Which one do we want to try first? 2 and 2. Factors of 5 are and the last thing we're going to do is check. (2x times -5 is -10x. 1 times 2x is plus 2x, giving us -8x. Would switching the 1 and 5 do anything? Because the first ones are both 2 and 2, it doesn't change anything. Which means 2 and 2 is out. I cross it out because every set of possible options we have with the third term, 1 and 5, has been used. There's no other way we can arrange it with 2 and 2, so it's gone. Okay. So we could put 4 in the first one, 1x in the second, and we can check this here. 4x times -5 is -20x. 1 times x is plus x, giving us negative, which is the correct middle term. And we get this here. Questions on this here? When finding the factors of each number, I would always start with 1 and then work your way down. And so the biggest thing I'd say, especially with factors, if I'm going to pick a number, say 52. I would start out with 1 and 52. Then we can say 52 divided by 2. So we have 2 and 26. 52 divided by 3. Have a repeated decimal. So on. So then we can do 52 divided by 4. 4 and 13. 52 divided by 5. It's not 1. 52 divided by 6. So 6 doesn't work. 52 divided by 7. No. I'm going to go on and say 52 divided by 8. Is that number smaller than what I just checked a factor for? Is 6.5 is less than 8, yes? We're done. Because that means any other factors after that have already been displayed. Because the next factor would be 13. It's already listed. Because once the two sides meet, our factors that are going up meet the factors that are coming down on the other side, we're done. That's as far as it goes. Because at that point, they will just start repeating each other back up the chain. Does that make sense? Yeah. So if it only has 1, it's just going to be 1 in the number itself. And those will still work the same way we just did. It's just you'll get, after 1, you'll have a decimal when dividing by 2, 3, 4, 5. And whenever those numbers meet, really we could have stopped at 7, because 7 and 7 point, whatever, they've really met. Okay, it doesn't have any, besides 1 in itself. Does that make sense? It's not really a method we actually teach, but it works. Now, here, 2 sets of parentheses with spaces because there's not a greatest common factor. Since the third term is negative, our signs are opposite, positive, negative. Because whenever that third term is negative, the signs are opposite. It's just, that's it. It's immediately opposite. The only time we look at the sign for the middle term is if the third term is positive. So here, they're immediately opposite. Now we're finding the factors of the first and third term. Well, 6x squared will have x and x. Now 6 will have 1 and 6, 2 and 3, well, and that's it. 12. 12, 2 and 6, 3 and 4. And as we see with this here, 3 and 4 met, because the only next factor we could check after that would be 4. It's already there, we're done. That's those only factors. Right. Let me get a different color.
And then the 1 and 6 and the 2 and 6 can't go together.
So 2 and 3, 3 and 4 could go together because the 2 can go with the 3, 3 can go with the 4. But we can't have the other. We only have one setup for it. Right, because 2 and 3, I can't have 4 and 3. Because 3x and 3x has the greatest common factor of 3. 2x and 4 has the greatest common factor of 2. If there's a greatest common factor in either one, we could factor it out. We can pull that common factor out. But was there one here? No, if we can't pull a number out of these three, we're not able to do it to these here. The only way we could pull one out of either one of these here means that there was one here to begin with that we just missed. And the reason that's helpful is because, well, this arrangement here we know doesn't work. So if we chose 2 and 3 for x, I know that arrangement doesn't work. I also know that 2 and 6 doesn't work because here we'd have 2x and 2. Here we have 3x and 6. Okay, that doesn't work. If I did 6 and 2, here 3x and 2 is fine, yes? 2 and 6 on the other. 2 and 6 is out for 2 and 3. And actually 1 and 6. Because I can't put 6 and 6 together. I can't put 6 and 2 together. Because it's gone completely. So we can do 3 and 4. I'm just picking the bottom one just to do this here. But again, with any of these here, even if all of what we just said kind of went over your head, that's fine. Pick a set of factors of each, plug them in, check. 2x times negative 4 is negative 8x. 3x times 3x is plus. So that's it. For the most part, yes. But as I've said the last few days, the more that you do these, the better you'll get at them. And it's faded some over the years, but the Algebra 1 classes that we were at my high school, all the Algebra 1 classes were required to take a factoring test, which consisted of 90 questions. We had 90-minute class period block scheduling, so you had to be able to factor all 90 in the hour and a half. And some of them were what we call simplified or simplified already. There wasn't a greatest common factor, and they didn't actually factor further, and you had to know those two. But yeah, and that's mainly what it is. So the more that you do these, the more that you'll see these here, because when I look at this here, the middle term is small. So most likely the factors have to be close together, our numbers that we're looking at. So I normally start there. If the number's really big, well, the factors are probably farther apart. Let's look at this next one. This one is a little bit different because our first term is not positive. It is negative. It's just more of factoring, more getting y'all used to these. Negative 4x squared minus 8x plus 5. Is there a greatest common factor? No. But there is something I do want to pull out. If that first term is negative, I'm going to factor out a negative 1. I want that first term to be positive. Yes. If a, the term in front of x squared is negative, we want to make it positive. And the reason is because step 3 really gets a wrench thrown into it, and 4, because step 3, well, I take that back. Step 3 will work the same. It'll still be the same that here, because it's plus, the signs are the same and they match the sign of the middle term. That is fine. Step 4, the factors of the first term, we're not going to look at just the factors of 4. We have to look at the factors of negative 4. So now we have to take those negatives into account. Does that make sense? Because we'd have to look at not just 1 and 4, 2 and 2. We'd have to look at negative 1 and 4, 1 and negative 4, negative 2 and 2, 2 and negative 2. We have to look at every case. But if we take that negative out, it's now just 4. We're looking at the factors of 4. Negative 8x becomes plus 8x. 5 becomes negative 5. And now it falls back in line with how all the ones we've done thus far. Now we don't have to keep writing negative 1 because a negative out front says the same thing. If you need, or it helps you to have it, write it as negative 1. Yes. Now when we look at the third term, if the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. So one's factors of 4x squared, we have x and x. And we will look at the factors of 4, 1 and 4, 2 and 2. And since it's now positive 4x, it's not the negative, we don't have to consider those sign changes. We don't have that issue. It's not going to come into play anymore. So now we're just looking at 1 and 4 and 2 and 2. Which one do we want to try first? 2 and 2. Factors of the third term are 5. So we have 1 and 5 or 5 and 1. I'm just saying that just based off how we want to plug them in. So we can do 5 first, 1 second. Two x times negative 1 is negative 2x. 5 times 2x is positive 10x or plus 10x, which gives us a positive 8x. Is that what we wanted? Because we're looking here, we're not looking at this one here anymore. Because we pulled the negative out, we factored out, we're looking back to this one here, not the original anymore. Does that make sense? Because that negative out front will adjust it back to negative 8x. And here, if we multiply the negative back in, once we finish distributing, it would reset it back to the original. Does that make sense? So our final answer is negative, parentheses 2x plus 5, close parentheses, parentheses 2x minus 1, close parentheses, is our final answer. Questions on this here? Okay. Questions on this here? We're going to do one more, and then I think y'all feel pretty comfortable. Feel comfortable with these here. Let's look at this here. Is there a greatest common factor? Well, no, but yes. We have the negative, and we're going to factor the negative out. And when we factor the negative out, it does not affect the value. Well, technically, it does not change the number from 9, 3, or 2, but it does change the value from positive to negative or negative to positive. Yes? Because what we're doing is dividing each one of these by negative 1. So dividing by 1 doesn't change the number, so it's still going to be 9, 3, 2. But when I divide by a negative, the negative and negative make a positive, negative, negative make a positive. Positive and negative give us a negative. You're welcome. Because a lot of times once we get to this point, it's just assume we see that and understand that, so we just skip the step of that kind of in between. Now, since the third term is negative, the signs are opposite. So one's going to be positive, one is going to be negative. We're going to look at the factors of the first and third term. Well, part of 9x squared, we have x and x. Factors of 9 are 1 and 9 or 3 and 3. Which one do we want to try first? Factors of 2. 1 first, 2 second. And the last thing we can do is check. 3x times negative 2 is negative 6x. 1 times 3x is plus. We need positive 3x. If we get the correct number, because 3x is the correct number, but wrong signs, we change the sign. Really, the only one we need to erase is the plus. Turning the minus into a plus is actually kind of nice. Add a line. And if we check this again, 3x times 2 is now positive 6x. Negative 1 times 3x. Negative 3x, giving us a positive 3x.
Wouldn't we times the negative 3x that we got the first times negative 1, and that would make it positive? Like, wouldn't it?
Where at?
Okay, we have the negative 1, which would be in
Here. Now, this is kind of a side note. I mean, we could multiply that negative 1 back in if we wanted to not have it sitting out front, but we can't multiply it with both. If I wanted to condense this, I would have to choose to multiply this negative 1 either here or here. It's got to go into one or the other. It can't go in both. So I can multiply it with the first one, which would give us negative 3x, plus 1 times 3x plus 2. No, because this is the same thing. Because if we multiplied it out, 3x times 3x would be negative 9x squared. Negative 3x times 2 would be negative 6x. 1 times 3x would be plus 3x, and 1 times 2 is plus 2, which gives us negative 9x squared minus 3x plus 2. Now, you might be saying that doesn't match this here. Well, it's not supposed to. It matches the original because we put the negative back into it, so it's going all the way back to the top. Most likely, you'll probably stick with this one here. Before y'all leave, 11 through 29 odd. 7 problems, I believe. Eleven, 13, 15, 17, 19, 21. No? 11, 13, 15, 17, 19. Yeah. 6 problems. Oh, no, I'm going to 20, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29. 10. Yeah, because 18 between them, count one of them. Yeah. Okay. Careful. You don't have to do 24.
Oh. Oh, crap. Whoops. There we go.
Okay. Remind me tomorrow.
I'm actually surprised.
I'm changing that.
I tried.
because, yeah, yeah, don't do 25, 27, or 29. Yeah, do not do those. I'm going to need to remind me to tell the class tomorrow. And if you see anybody from our class, from your class, tell them.